Hello, I am Paul from University of North Carolina at Charlotte. I'm very happy to have an opportunity to present my work even in this hard time. Here, I'd like to talk about the multivariate neighborhood trajectory analysis. Today, I'm going to introduce a new neighborhood trajectory model to explain neighborhood dynamics in a longitudinal perspective. I want to introduce functional data analysis approach to deal with complex temporal data very easily by taking time series data as multivariate curve that proceed on time. Geographers have had a long-lasting question about the city. How are cities spatially structured? To answer this question, early theoretical models were suggested. For example, concentric model, sector model, multiple nuclei model, which are classical models on the undergraduate textbook. These models well explain the spatial structure of cities in the United States. Based on these ideas, empirical studies have tried to explain why and how cities are divided cross-sectionally in reality. Researchers use mostly census data, which is published in every decade. And in order to analyze the multidimensional complex data, dimension reduction techniques such as principal component analysis and self-organizing maps were used. And in order to classify and identify different groups of neighborhoods, classification techniques such as k-means clustering, hierarchical clustering were employed. Those academic works were very helpful to extend our horizon of knowledge about our reality and neighborhood division where we are living now, like racial segregation and income segregation issues. Actually, the focus of geographers have moved from the cross-sectional to temporal dimension. That is the longitudinal neighborhood changes. They started to question how neighborhood change over time and what is the underlying longitudinal trend. When we actually look back our reality and we see the neighborhood differentiation, we get to realize that such segregation structure evolves over time, not emerge at once. We see that many cities' income segregation and racial segregation has evolved from the redlining, which is made in early 20th century, white flights, transit developments, gentrification. All of those issues are processes that proceed on time dimension. However, adding time dimension in the analysis is very tricky and complex. So let me introduce about the existing models for neighborhood trajectory analysis, Markov chain, and neighborhood sequence model. Markov chain analysis examines the probability and stochastic propensity of year-to-year changes. In a similar sense, neighborhood sequence analysis extracts cluster of neighborhoods that have a similar sequential patterns. Both approaches use cross-sectional neighborhood classification in each year and stack them together, stack a series of classes as a sequence. For example, all panel data are pulled together and each year tracked is classified based on the similarity of neighborhood attributes. A sequence, for example, let's see the track 30. It has the sequence and its status switch from A to B, B to C, and then A, D. Like this, each sequence is assigned to each tract. And the sequential pattern is analyzed in Markov chain and neighborhood sequence analysis. In other words, neighborhood change is represented by the discrete and this stepwise changes. And this is a stylized procedure of the discrete and stepwise neighborhood trajectory models. It starts from the census panel data, and census panel data are z-score standardized across each year. The dimension reduction is done for the simplification of data structure. Then neighborhoods are classified, and the classified neighborhood classification are stacked together, and each tracks gain a sequence of neighborhoods classification. And this sequence is analyzed by Markov chain or sequence analysis. As you see, neighborhood changes are described as a sequence, which is categorical and discrete and stepwise changes. However, it is more natural to think that neighborhoods are changing continuously. Even at this time, neighborhoods are changing, and this change proceeds on the time continuum. And all of neighborhood changes are time-dependent process, rather than they are independent from each other, as Markov chain model assumes. As an alternative to the existing discrete stepwise neighborhood trajectory model, I would like to suggest a model that takes continuous neighborhood growth process that proceeds on the time continuum. So let me introduce about the functional data analysis. Functional data analysis, or FDA, deals with the function, and I mean the mathematical function. In the FDA, a set of variables can be treated as a function of continuum, such as time and space. And the most usual application of the FDA is handwriting, which is basically the time-dependent function or a curve. And there is a starting point and a starting time, and there's ending point and the ending time. And if we use this idea of FDA in the longitudinal neighborhood analysis, time can be embedded in variables, and temporal changes of neighborhoods can be expressed as a function of time. If we can examine the patterns of the time-dependent curve, we can compare and contrast longitudinal patterns of neighborhood changes. So basically, FDA can simplify the analytical process of neighborhood trajectory analysis. Once we do the curve fitting and convert the census panel data to the multivariate time-dependent curves, we can apply multivariate functional principal component analysis, or MFPCA, for dimension reduction. Then, application of k-means clustering on the multivariate functional principal component scores will provide a set of neighborhood trajectories. And neighborhoods in each trajectory follow a similar patterns of neighborhood changes over time. So let me explain more about the multivariate functional principal component analysis. Given that we have a census panel data and it's stacked by time, we can apply the curve fitting process that will produce the multivariate functional data. And these multivariate functions can be decomposed into the infinite linear combination of basis functions. And if we apply the multivariate functional PCA and take the first few principal components, we can take simplified functional data that sufficiently explain the functional variation. So I'd like to give more comparison of between the classical PCA and the functional PCA. And the classical PCA is for dimension reduction of point data or cross-sectional data. But the functional PCA is for dimension reduction of function or curve data or longitudinal data. Extracting the functional principal component scores can provide information about the characteristics of functions of curves. And if we apply the clustering analysis on the functional principal component scores, we can classify curves based on the longitudinal patterns. By doing this, we can identify underlying major neighborhood trajectories. For the experimentation, I apply my new neighborhood trajectory model to census tracts of Charlotte and Detroit metro areas. Using 16 variables shown in the table, I constructed 16-dimension neighborhood curves and apply my new model to the functional data. This is the curve of the educational attainment in Charlotte metro area. And I applied the functional PCA, and I was able to identify curves with similar longitudinal patterns, which is coded by color. And I averaged curves by the identified clusters to represent major neighborhood trajectories. So my new model identifies 8 neighborhood trajectories in Charlotte. There is a clear delineation of trajectories between inner city neighborhoods and suburban areas in Charlotte. The first neighborhood trajectory identifies inner city persistent struggling neighborhood. This neighborhood experienced persistent struggling throughout the whole period, and the socioeconomic status has been very low across all years. The housing environments has degraded constantly over time. The second neighborhood trajectory is inner city persistent elite neighborhoods. Compared to the previous one, the socioeconomic status has been very high, and the major population has been continuously white population. You can see a clear segregation between these neighborhoods and the first neighborhoods. The third neighborhood trajectory shows inner city urban mixed neighborhoods. The white population has decreased from 90% to the 30%, while the foreign-born population has increased from almost 0 to 25%. And there is a mixture of racial groups in these neighborhoods, and the multi-unit housing has risen quickly between 1970 to the 1990. On the suburban sides, I'd like to show 2 neighborhood trajectories which take very different paths. This pink-colored neighborhood trajectory shows suburban upgrading to elite trajectory. The major population has been whites, but the socioeconomic status has risen very sharply over time. If you see the poverty and educational attainments rates increase over time. This shows a suburban changes toward a stable and rich neighborhoods. And the other purple-colored neighborhood shows very different patterns. We can see that a fast decline in white population and rise in the black population, and that shows a white flights phenomenon very significantly. With this change, socioeconomic status has declined slowly to middle level, which shows suburban changes to the middle class neighborhoods. Let's go to the Detroit areas. I found 10 neighborhood trajectories, and the result shows a very famous donut segregation structures in Detroit, and you can see a very clear separation between inner city and suburban neighborhoods in Detroit area. The first trajectory shows inner city persistent struggling black neighborhoods. These neighborhoods have experienced persistent deprivation throughout the whole period. These neighborhoods have maintained extremely high poverty rates and unemployment rates, and the declining trend of the socioeconomic status has never stopped. There is a skyrocketing housing vacancy rate and high proportion of old housing. The second trajectory shows inner city only downgrading Black neighborhoods. They are located in right outer to the previous one, and they have experienced early white flights and declining socioeconomic status, which started in 1970. In 1970, the proportion of the Black and white population were almost equal, but in 1980, Black population became a major racial group. A notable change is that the old housing rate increased from 50% to nearly 100%. That shows a very serious deprivation in these neighborhoods. The third trajectory with pink color shows that the inner city late downgrading Black neighborhoods. There is a 10-year time lag from the previous neighborhoods. And when the white flights finished in 1990 in these neighborhoods, the proportion of whites and Black population were almost equal. From 1990, the major racial group has changed into the Black population. The socioeconomic downgrading has followed the first few trajectories. The fourth trajectory shows inner city downgrading neighborhoods, but with mixed racial group. The socioeconomic downgrading pattern is similar to the second trajectory, but there has been a consistent rise in foreign-born population, which seems driven by the rise in the Hispanic population in these neighborhoods. Also, we can check the neighborhood trajectories existing in suburban areas. These first neighborhoods placed immediately outer to the inner city neighborhoods. And this trajectory shows suburban, stable, middle-class neighborhoods. The residents have been in the middle class as the socioeconomic status has been in the stable range, but it has been lower than other suburban elite neighborhoods. The major racial group has been white across all years, and there is a clear distinction between these neighborhoods and the other suburban elite neighborhoods, and this shows neighborhood segregation within the suburban areas. And this is very different, very different from the traditional view on the segregation, which happen between inner city and suburban areas. This trajectory shows a suburban persistent white elite neighborhoods. These neighborhoods have maintained a high socioeconomic status throughout the whole period. The major racial group has been white population, and the rate of professionals have been very high, and poverty and unemployment rate have been very low. This indicates that the residents of these neighborhoods are in the elite group, and these neighborhoods are not much impacted by the fast deindustrialization in Detroit. The other suburban neighborhood colored with orange shows a trajectory of suburban upgrading to elite. This neighborhood has transformed from the stable middle class to elite neighborhoods. As we can see, the fast rise in the professionals and educational attainment. The poverty and unemployment rates maintained at the lowest level. The trajectory patterns found both in Charlotte and Detroit areas tells us that there has been increasing racial segregation and increasing socioeconomic segregation between inner city and suburbs. And there rise another segregation pattern between the suburban neighborhoods. And all of these changes happen together with the industrialization in both cities. So let me wrap up this presentation. FDA-based approach addresses a neighborhood growth process as a time-dependent and continuous curve by taking a multivariate curve as a unit of analysis. And that allows us analyze the spatial temporal, neighborhood data very easily. And by comparing the curve shapes, MFPCA and clustering can identify neighborhoods which have similar neighborhood trajectory patterns. If there is any question from the audience, I would be very happy to answer. Thank you very much.